I think it's time to begin. First, before we do this, we should apologize for wasting your time. Second, it's your fault. You're in here. So, here we go. Welcome to our talk. I'm Chet Haase.
And I'm Romain.
And today we're going to talk about ISO 9004.1, specification of quality management process in the specific realm of computer science, or as we like to call it, Equivalence.
So we're not very happy about this acronym, so we came up with a new one called quality. It of course stands for quick update and like is totally yup.
We also wanted to come up with a better name that really enforces how strongly we feel about quality. So in the style of Steve Ballmer, quality, 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 or
Q14.
Turns out there are actually 15 qualities in there, so we have a
off by one error
quality issue. The agenda that we'll be covering today. First, we'd like to talk about ourselves, and you'd like to hear it. And then we'll go on and cover some very important things, as the agenda says. So, first of all, here's a little bit about me. I run a company called Quality Consultants Incorporated. I am the president, founder, CEO, CTO, chairman, and owner of the company. I am also a consultant. I have many years in engineering and, very importantly, many years creating bugs. However, from 2015 until now, I have focused exclusively on presenting about quality, and during that time, I have created 0 bugs. I do have an important certificate of quality, which we'll get into shortly, and once again, 0.
I also work for Quality Consultants Incorporated. I am the Chief Quality Officer, or the QQO. I'm also the Quantitative Quality Quack, or QQQuack. I am the only employee, and unlike Chet, I have no experience whatsoever, so I've also created 0 bugs in my entire career. That's why I do own a certificate of quality. And I will emphasize 0 again.
Speaking of certificates, here's what mine looks like. So there's a couple of things I want you to notice here. First is that it says quality not once, but twice. Second is that it says my name, because it's mine. And finally, I would like you to look at the level of quality in the certificate itself.
I also have my own certificate. You can see it right here. It's just as good as Chet's.
All right, so what does everyone mean by quality? Well, I like to look at the derivation of language, so we can look at the Latin roots of the words. Qual, of course, stands for what? IT in Latin stands for IT, and Y stands for Y. So if we put this all together, of course, we have what? IT, Y? Which I think is self-explanatory. But if we look at it instead in the German derivation, then we get something very similar, except qual translates as torment. So why do we torture ourselves with IT? And I would argue that it's a quality problem.
We found this quote that apparently is about quality. We don't know who it's from. Does anybody knows what it means?
Doesn't actually matter, but there is a quote about it. So,
anyway. So I wasn't happy with the Chet's derivation, and I've been studying French for a few years, so I decided to look at the word quality in French. So it starts with K, which means only, followed by li, which means bed, and finally Y, which means there. So only bed there, which in the words of Voltaire, a famous French poet,
probably.
When the product is so bad, one can only sleep. And we think that relates very well to quality.
Okay, so that's what the words mean, but what do we mean by quality? Do we mean tests? Do you think that tests are what we mean by quality? Let's do a little poll here. I see like one hand. No, everybody else is asleep. All right, so we're not thinking tests. Well, things like load tests, all the rest of these tests, like are these important in quality? And I would argue yes. So all of you were wrong.
what about quality metrics? For instance, here are a couple metrics. The green line, when the defects go down, quality goes up. Are metrics important? Raise your hands. Like more people.
Okay, more people.
Yes,
They're learning.
right.
They're learning.
They're getting it.
All right. And finally, do we mean eliminating bugs? Is that what quality is? Is that what we should be after in searching for quality? Who thinks eliminating bugs is important? All right, you're wrong. So I came across this quote, which I'm a particular fan of, which goes like this: quality software has no bugs to eliminate. So if you're getting rid of the bugs, then by definition, it wasn't quality to begin with and never shall be.
And I think it was you who said that?
I was, yeah, it was my quote. Yep.
And now we want to look at a very important equation. We found that having equations make us look smart and appear that we know what we're doing. So we have one. It's called the Equivalence Theorem of Code, or ETSI. And it goes like this. The number of bugs in your code is a function of the number of lines times the number of
files
times the number of statements
times the number of conditions in the code.
So then you take this multiplication and you square it. We're not quite sure why, but we see squares a lot in equations.
It's a common thing in equations. It's also really common to see things summed over values, especially in equations with this many Greek letters in them. And usually the summation is done as x goes from 0 to infinity, so that's what we do here as well. I'm not sure what x is here, but it's used in the sum.
And because math, just like engineering, is not an exact science, we have this error term that we add just in case.
So given this equation, we can come up with the exact number that represents the bugs in your code or the lack of quality in your code. So it's important to also look at the metrics. I think charts and data are most important for managers that don't understand actual information. And so as engineers and as people in organizations, we should be able to produce these charts and data and metrics. So let's look at some now. So where do the bugs live? Do they live in the documentation or the specification?
No, they don't. Are they in the specification?
They are not in the specification or the documentation.
Are they in the memos?
I don't think so. What about the emails?
Never seen a bug in email.
Desk drawers?
I have seen bugs in desk drawers, different kind of bugs.
Yes, they are. How about the monitors and displays?
No.
Conversations that people have in the hallway? The meetings that they have in the conference rooms?
No. How about code?
All of the bugs live in the code. All right, all of them. Remember that. We'll come back to that. All right, how about the people who write the bugs?
So, is it the salespeople?
I don't think so. What about marketing?
No. Administration?
No.
And we can keep going on and on. Cleaners, baristas, security guards.
None of those people.
There is one category, however, that surprised us: management. This was a project we worked on together. There was this manager who used to be a software engineer, and he thought he could still write code. Actually, he could still write bugs.
Yeah. But other than that, all of the bugs come from the engineers, right? So you end up with this sort of relationship where you can compare the number of codes, the amount of code over time to the number of bugs over time. So we worked with another client and came up with this excellent data and chart here. Now, there's a weird anomaly in the middle of the data, though, where at some point the amount of code actually went down and the number of bugs went up, and we wondered what was going on.
So what happened was one of the engineers decided to do a refactoring. He messed it up and deleted a bunch of code, which created, obviously, a lot of bugs. We fixed the issue, we fired the engineer, and the number of bugs went back up with the number of code. So what do we want?
So in general, we want the number of bugs to go down. And through the equations and the information, the charts and data we presented, obviously this means that the amount of code has to go down.
So how can we achieve that? So first we're going to talk about some of the common misconceptions around quality. We call them the believable solutions, or BS. And the first one that you probably already know about is called the Guidelines and Ground Rules of Methodology Excellence, or GAGME for short. It goes like this. You first identify processes, you document approaches to those processes, you form teams that will discuss methodologies to implement those processes, you present the findings to the rest of the team, you train the teams, And finally, engineers write code. So if we look at those different steps and we try to figure out where the bugs happen, they don't happen here. They happen only when the engineers get involved.
What about the better specifications methodology or another BS? We comprehensively identify the requirements for the product, we identify the problems ahead of time, and we propose solutions to those problems, and then the engineers write the code. And once more, we find that none of the beginning steps created the problem. It was all about the engineers writing the code.
So there's another very popular approach to quality. It's the code review approval process that I'm sure you all use, or called CRAP. But the way you think it works is like this. An engineer writes code and then submits that code for review, and the other engineer reviews the code, and the first engineer fixes the code. And finally, you can submit bug-free code. So let's look at what happens. We have bugs in the original code that was written. Then during the code review, no bugs are created. Then bugs get fixed, they're gone, and we can submit bug-free code. But here's what actually happens. The engineer writes code, sends it for review, there are still no bugs, but then the original engineer writes more code, which means that we submit more bugs.
How about product management supervision, or PMS? So the product manager will identify the features for the project, tell the engineers to implement those features, track the features as they are implemented.
And usually the way they do this is the PM stands behind you and goes, "Are we there yet? Are we there yet? Are we there yet?" Until you're there.
And finally, the engineer writes the code. First step, no bugs. Telling the engineer to do things, no bugs. Actually tracking the implementation, no bugs. It's the writing of the code that causes all the problems, right? Are we getting this finally? It's pretty complicated. How about work hours is never ending, right? Or whiner. So the engineer will write some code that creates bugs, as we know. Then they will stay late to fix the bugs, writing more code, which creates more bugs. Then they feel really bad and they're really tired, so they stay even later, they get tired, they write more code, and they create many, many more bugs. And then they sleep, which creates no bugs.
So I believe by now you've found a pattern. Where there is code, there are bugs. So what can we do about it? So we know what we want. We know that the number of bugs will go down with the amount of code, so we want to reduce the amount of code. And there are different ways you can do this. First, you can make up the data. You can pay us to make up the data for you. Or you can fix your organization. And we're going to look at this. We call that fixing the problem, or FTP. But Chet didn't like the acronym, so he came up with a better one, HERO.
All right, so this is a typical engineering organization. We have management at the top, then we have a bunch of leaf node engineers working together. They all work on their workstations across this intranet, and they submit the code out to the internet, and that's where the customers get the bugs, right? So we looked at the problem. We thought, well, how can we fix this piece by piece?
So the first solution is to remove access to the internet. If the engineers don't have access to the internet, they won't be able to ship the bugs, problem solved. Unfortunately, engineers are really good at finding other ways to access the internet, like using their phones in their pocket or going to the local coffee shop. So that was not enough.
All right, next step, let's remove the intranet. If we make it impossible for the engineers to talk to each other, then clearly they can't get their jobs done. It turns out that engineers don't like people to begin with. They were perfectly happy working on their own, so this didn't stop them either.
So the next step we took was to just remove the engineers' workstations, because if they don't have workstations, they won't be able to write code. See, I always do that. Anyway, so unfortunately that was not enough. They found other ways. They brought their own laptops from work, from home. So we decided the real step to take was to get rid of all the engineers and keep only the managers. No engineers, no more bugs.
This was the solution. At this point, that particular company stopped producing code, stopped producing bugs, and therefore had quality products.
So we call that hire more managers, or And let's look at why it works. So here's what managers do. Managers manage people, but they do not write code.
Managers attend meetings, but they don't write code.
They talk with other managers, but they do not write code.
And finally, managers facilitate cross-functional growth strategies and interdepartmental team facilitation for the purposes of collaborative interfacing and departmental-wide coordination, but they do not create bugs.
So what about sales? Because in the end, you still need to sell your product to your client. So here's a typical life cycle of an application at your company. So you have your first version, release 1.0, it's full of bugs. You sell it to your client. Then you have release 1.1, more bugs, you can sell it. And you go on and on and on. Finally, here we reach version 2.3. And we reach this point that we call corporate realization or company knowledge, or CROC for short. And that's where we get rid of all the engineers. But the trick is to re-release version 2.3. You just call it 3.0, and you keep going. So then 3.1 is still 2.3, and you still don't have new bugs because you got rid of all the engineers. And I think that's why when you go to the app stores or the Google Play Store on your phone, all the release notes always say bug fixes and improvements. That's because they have nothing to say. It's the same app that they keep shipping again and again and again.
Tried and true. It works. All right. But I think most of you are engineers in the audience, and so you're probably thinking about this last methodology. What about engineering? So you've told us that the approach to quality is to eliminate engineering, so what is it you are all going to do? Well, you're not going to do more coding, which means you're not creating bugs, which means that now you are, by definition, creating quality, which means you're building expertise in quality and you have become an expert in quality. And now you can give presentations in quality just like this. I believe we're at the Q&A part of our presentation, and we wondered if you have any quality questions. Or kuka. Yes? Could we go further to improve the quality? Well, you need to basically find all of the elements within your organization that can produce code, since without code there is no bugs. There are no bugs. So you could certainly eliminate the managers that think they're engineers. You could, in fact, if you eliminated all of the people in the organization, then by definition there's no way that organization could ever produce quality. So yes.
And it's a little tricky. For instance, you look at sales, you need the salespeople, but they use spreadsheets, and sometimes they write equations in their spreadsheet. That's kind of like code. So once we had a client who fired all the salespeople, but then they ran out of business, their business went down because they were not selling anything anymore. So be careful, don't go too far.
Yes, way up there.
If engineers don't create bugs when they sleep, should we train them to write code in their sleep? Instead of sleepwalking, you sleep code.
Should engineers write code in their sleep since they're not creating bugs? So that's a very ridiculous premise. Very interesting premise. So our assumption in coming up with that particular methodology was that they were not writing code in their sleep. Otherwise, they would, by definition, again, through that equation that we saw, if they're writing code, they are creating bugs. So even if they're writing it in their sleep, which I think that's an interesting approach, and I would like to see that happen, but I also doubt that it would create quality. Yeah.
Is this new methodology they're thinking about called testing? You can sometimes apply it at the end of a project, just like spraying a bit of gloss on a nice bit of code, and apparently that improves your quality. Have you thought about implementing something like that?
So have we heard about this new methodology apparently called
Testing?
Testing. I haven't personally, but apparently at the end of a project, you can run tests that verify the level of quality in your product. Now, correct me if I'm wrong, but if you've ejected a bunch of bugs, you're not going to have perfect quality, and therefore the tests are just proving out exactly what we talked about.
Also, someone has to write code for the test, and if you write code, there are bugs, so you're not helping at all here.
Yeah. Yeah.
We also discovered that the less you test, the less bugs you find, which is good for quality.
Also, it's probably important to point out that we do training on quality and presentations on quality, and that's what we're paid for, so we have zero interest in talking about tests. Yep. Yes?
It's better to remove all the infrastructure, so you cannot run the application.
Could we remove the infrastructure so that we could not run the application?
But see, that's why you're wrong. We still need to make money, so we need to sell the application, and the application has to run.
And we did try removing all the infrastructure from that company, except engineers are tricky. They will always find infrastructure. They're attracted to it like conference attendees to conference sandwiches. Yes?
I realize that in all your presentation you never mentioned reporting, and reporting seems to be a shockingly important part of quality.
So we never talk about reporting in our presentations, and that is apparently an important thing.
What kind of reporting?
You mean like reporting to the police?
Any kind of reporting.
I mean, we have a bunch of managers. They report to each other. That works.
Inter-manager reporting.
Inter-manager, yeah, they report to each other. I think that works. There's news reports. There's all kinds of reports. We just don't talk about them because we hadn't thought about it. Yes?
We just recently discovered that even though shipping a version with a new number, customers would create bugs. At least they weren't there with the previous version, and there was no code.
So you're saying that even when you ship the same version over and over with the different version numbers, the customer creates bugs or reports bugs, right?
Well, they report bugs, so probably they also created them.
No, that's okay, because remember, the customer is always wrong.
So somebody had asked whether we could take this further, and I think this is an interesting avenue to explore. Would it be possible in that case to, instead of just eliminating engineer, actually eliminate customers as well? The trick with doing that is to eliminate them after the sales.
What's your take on the no-code movement?
What's our take on the
No-code movement.
no-code movement? I'm in favor of no code everywhere. No code still, no code moving, no code. I have no idea what that is. But if there's no associated with the word code, then I think that is the way to go.
If you're going for no-code in GitHub, then you're going to find a project with that track. I think it's going to fit.
Okay. Apparently there's a GitHub project, which means there's going to be code, which means it's a lie. All right. Yes?
What if you remove the user but not the customer?
Oh, wow. What if we remove, so instead of eliminating the customer, which could eliminate sales, we remove the user instead of the customer. We have an opening in our company. We need some ideas like that. Yes. Let's go with one more question here.
Should we fire the DevOps?
Should we fire the DevOps? Well, if you don't have code or engineers, you should not have DevOps either. Again, all you need is managers and sales. Everything else doesn't matter.
Focus on what matters. Companies need to make money. Thank you.
Thank you.